Welcome to Module 203G on HVAC rooftop units. For commercial heating, cooling, and air management, these units have similar concepts to the residential heaters. However, they are organized in different orientations. This module has four different objectives to go through, and we're going to start with looking at the individual components that make up an HVAC unit. Rooftop units are a single unit that will provide heating, cooling, and ventilation for an entire building, and they're separated into three sections within the unit. The first section is the heating section, which is the heat exchanger and the burner area, and this is very similar to what we've seen with other heating systems. The next area is the cooling section. This would contain the evaporator, the condenser coil, and the compressor. The condenser coil and the compressor are towards the back of the unit, and we can see the fans that help draw the air through the condenser coil. Lastly, we also have the ventilation section, which consists of a blower and a blower motor and provides air circulation for the entire building. It will pull the air from the building through both the evaporator coil and past the heat exchanger. The heating section has similar components to those that we've seen in a residential system already, and we should be able to identify them. We have mechanical components such as the burners, the gas valve, the gas line, and the ignition assembly. We also have our electrical components being our igniters, whether that is a direct spark igniter or a hot surface igniter, as well as our gas valve coil, our fan switch, combustion blower, and safety components, as well as any airproof switches, rollout switches, flame sensors, high limits, and a door switch. All these different things we've seen already in the residential units. With the heat exchanger, we'll have the flue, the heat exchanger tubes, as well as the air intake. In the cooling section, we should also be able to identify the different parts in relationship to what we saw on the residential side. We will have a compressor or possibly multiple compressors. We'll have the condenser fan motor. We'll have the low and high pressure switches. We'll have the crankcase heater and an evaporator coil and the condensing coil. On many units, the compressor is kept on the heating side of the RTU since it will create heat, and the evaporator is in a completely different section. The ventilation section consists of the blower and the blower motor, and it is responsible for drawing not only air from inside the building, but it is also responsible for drawing air from outside in order to introduce fresh air back into the building again. It does this with either an automatic or manual damper to control how much fresh air is mixed in with the return air from the building. This also directs the air past the heating and the cooling sections. Let's take a look at this rooftop unit and analyze how the air is moving through it. On the bottom right of the screen, we see the air intake where we have air coming into the bottom of the unit from the building, and we also have the outside air coming in from the side. And this is all balanced either manually or automatically depending on what the system conditions are. After that, all that balanced air is now drawn through the evaporator coil by the blower motors. The blower motors then push the air past the heat exchanger, and then the conditioned air, whether it's been heated or cooled, has now been returned to the building. Our electrical installation depends on the nameplate information that we can get off the unit itself. We start with the voltage. The unit should tell us what our voltage is as well as what our phase is. This unit is 208 or 230 volts single phase. This will identify for me how many conductors do I need to bring up to this unit. Since this is a single phase unit, all I need to do is bring up two line conductors. I know it's two line conductors because it's not 120 volts, it's 208 or 230 volts. The next thing I have to consider is what my fuse size or my breaker size is going to be. And this is what the manufacturer tells me I need to install for this unit. This unit must be on a 45 amp breaker. And lastly, we're going to look at the minimum circuit ampacity of being 30.7 amps, which will determine my conductor size, and we also have to consider the environment. The type of conductors I use will depend on the environmental conditions that they are exposed to, whether they need to be run in a damp area or if everything's going to be completely dry. The manufacturer has already taken into account all the different rules that we have with motors in section 28, so the things that we talked about when we talked about the individual air conditioning systems in the previous modules, we don't need to apply to. All we need to do is follow the information on the nameplate in order to correctly wire this unit. A disconnecting switch is required for all units, and what we must pay attention to is how many live lines do we have. Is it a single phase unit with 2 hot wires? Is it a single phase unit with 1 hot wire? Or is it a 3-phase unit that would have 3 hot wires? These are all different things I need to consider, as well as what is the amperage rating of my circuits. My disconnect switch must be rated for not only the voltage and the amperage of my circuits, but we also need to make sure that they are mounted within sight and within 3 meters. Typically, they're installed on the side of the air conditioning unit in a convenient place that you can work on it safely. You have now reached the end of this objective. Review your module, complete the knowledge check, and then continue on to the next video.